Imagine turning crude oil into gasoline or separating alcohols with pinpoint accuracy. This is possible with the magic of fractional distillation. Ready to discover the science behind it? Let's get cracking. Fractional distillation is a separation technique used to separate miscible liquids. Miscible liquids are liquids that mix together, for instance, water and alcohol. Fractional distillation separates liquid mixtures with close boiling points. For example, methanol with boiling point of 65 degrees and ethanol with boiling point of 78 degrees. This technique refines crude oil into valuable products like gasoline, diesel, and jet fuel. The process takes advantage of the different boiling points of hydrocarbons. In fractional distillation, the choice of apparatus is essential. The setup typically includes a distillation flask, a fractionating column, a thermometer, a condenser, and a collecting or receiving flask. Distillation flask, our brave container hosting the liquid mixture. The distillation flask serves as the container for the liquid mixture undergoing separation. Fractionating column, packed with beads that act like bouncers at a club. Here's a riddle for you. What's something you can't see but can separate liquids with? Hint, it's the key player in fractional distillation. Keep watching for the answer. The fractionating column contains beads that condense the vapor with a higher boiling point back to the distillation flask while allowing vapor with a lower boiling point to escape. In industrial fractional distillation, the fractionating column is lengthy and designed for efficient separation. The column provides multiple vaporization condensation cycles, enabling a more precise separation of components based on their boiling points. The temperature gradient within the fractionating column allows for the gradual separation of components, creating distinct layers or fractions that are collected at different levels. This results in a more refined and pure product. Thermometer, the referee, ensuring precise separation. The thermometer is used to monitor the temperature of the vapor escaping from the distillation flask. Condenser, the MVP, turning vapors back into liquid. The role of the condenser is vital in converting the vaporized components back into liquid form. Efficient condensation ensures a higher yield of the desired product. Collecting flask, the treasure chest holding the final product. The collecting flask receives the final product. The composition of each fraction can be analyzed to determine its purity. This is especially important in industries like pharmaceuticals, where pure substances are crucial for manufacturing drugs. The boiling stones are added to the distillation flask to ensure a smooth heating process and prevent superheating and bumping. Temperature monitoring through the thermometer is essential for identifying when each component begins to vaporize and condense, aiding in the accurate collection of fractions. It's important to note that efficient cooling is maintained by allowing water to enter from the bottom of the condenser. Beyond just separating liquids, fractional distillation plays a critical role in the production of essential oils, alcoholic beverages, and even in environmental processes like water purification. Did you know industrial fractionating columns can be as tall as a 30-story building? To recap, fractional distillation is a separation technique used to separate miscible liquids with close boiling points. A speed challenge. Can you summarize fractional distillation in one sentence? Share your best one-liner explanation in the comments. When the mixture is heated, a liquid with a lower boiling point evaporates first. The fractionating column condenses the vapor with a high boiling point back into the distillation flask. The escaping vapor is then cooled into liquid by the condenser and collected by the collecting flask. If you can explain this process in under 30 seconds, you've officially mastered it. Post your 30-second explanation in the comments. Fractional distillation doesn't just separate liquids, it fuels industries, creates medicines, and even helps purify water. It's not just a technique, it's a cornerstone of modern science. Now that you've unlocked the secrets of fractional distillation, in our next video, we'll explore the wonders of simple distillation. Trust me, you won't want to miss it.